Let's explore the fundamentals of MapReduce. This is an understanding of the programming model for big data processing. MapReduce offers a simple way to handle distributed computing. So, what exactly is MapReduce? MapReduce is a programming model designed for processing large datasets. It works by distributing the data across clusters of computers and processing it in parallel. Three key characteristics include: it divides the work into smaller tasks, it processes data in parallel, and it handles fault tolerance automatically. MapReduce operates in two primary phases. The first phase is the map phase. It transforms input data into key value pairs. The map phase processes each record independently. The second phase is the reduce phase, which aggregates and combines the mapped results. The reduce phase groups by key and applies reduction. Here's an example of a map function. Consider a word count scenario where the input consists of text documents, and the goal is to count the frequency of each word. The map task involves extracting words and emitting word in one pairs. This is a Python code for map function, defmap_function, document, words equals document.split. For word in words, word equals word.lower open parenthesis close parenthesis, strip open parenthesis close parenthesis, emit open parenthesis word comma 1 close parenthesis. For the input hello world hello, the output is hello comma 1 world comma 1 hello comma 1. Let's look at an example of a reduce function. The aggregation process takes grouped key value pairs as input, and the goal is to sum all values for each key. The reduce task combines these values to get a final count. The Python code for reduce function is defReduce_function, key values. Total equals 0 for value in values, total plus equals value, emit key comma total. For the input hello 111, the output is hello comma 3. The MapReduce workflow involves several key steps. First, we have the input, which is a large dataset split into chunks. This is followed by the map phase, where each chunk is processed in parallel. Next is the shuffle phase, where data is grouped by keys across nodes, automatically redistributing the data. Finally, we have the reduce phase, which aggregates the results by key. MapReduce offers several key benefits. It provides scalability, which means it can handle petabytes of data across thousands of machines. It provides fault tolerance, meaning it automatically recovers from hardware failures. It also allows for parallel processing, distributing computation across cluster nodes. Finally, it offers simplicity by abstracting complex distributed computing details. MapReduce has numerous real-world applications. Some of the common use cases are log analysis and processing, search index generation, business intelligence, and machine learning training. Popular frameworks that implement MapReduce include Apache Hadoop, Apache Spark, Google Cloud Dataflow, and Amazon EMR. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.